Well, thank you for joining us this afternoon on WFRV Plus for this special interview talking about the 50th anniversary of the sinking of the SS Edmund Fitzgerald. I'm Storm Team 5 meteorologist Ryan Kudish. Before I introduce my guest this afternoon, make sure to catch the full show airing right here on Local 5, November 10th at 6:30. Joining me this afternoon is the former Vice Chancellor for Research and Graduate Education at UW-Madison and Emeritus Professor for the Department of Atmospheric and Oceanic Sciences at UW-Madison. My guest is Dr. Stephen Ackerman. Dr. Ackerman, thank you for joining us this afternoon to talk about this.
Oh, it's my pleasure. This is a very interesting story and a weather event, which is a lot of fun too.
Yeah, talking with two meteorologists. This is certainly going to be a show, so sit back, relax, and enjoy the ride. Different, eras of meteorology for sure, but this is bound to be a really cool show. So we appreciate you taking the time to join us today.
Yeah, I look forward to hearing what you have to say as a professional meteorologist.
I don't know if we're professional just yet, but we'll get there eventually. But, I kind of just introduced you a little bit, but what's your background? How did you get into, meteorology and, what led you to where you're at right now?
So what got me into meteorology was I went to upstate New York to one of the state universities up there, Oneonta, for a physics degree. And at that time in the 70s, physics was about a lot of stuff you couldn't see. And that's not the kind of physics I wanted. And so somebody suggested, you ought to take a meteorology course because that's just applied physics. And I did, and I really enjoyed it. And so I switched. It became a physicist, meteorologist as an undergrad, and then also got involved with some research and wanted to stay in the research environment. And that went out to Colorado State University for my master's degree and PhD and worked there for a while before coming to UW-Madison.
Yeah, and I remember, listening to that radio hit you did with La Crosse, and you actually mentioned that you remember where you were when you heard about the sinking. You were doing some maps for you're in college. So if you could tell that story, because I thought it was pretty interesting.
Yeah, so what I used to do as one of my jobs, I was a senior at Oneonta at that time, was to go in early in the morning and hang weather maps, right? We didn't have technologies like we have today, so you had to hang them all up on a weatherboard. And when I went in to do that, I saw the newspaper article about the Fitzgerald sinking on this Lake Superior. And when I read that, I grew up on Long Island, and so I was very used to swimming in the ocean. And when I saw that article, I just could not fathom that a boat that big, a ship that big, could sink on a lake. What kind of storm, what kind of lake was that could take down or ship like that was over 700 feet long? It was just amazing. I just couldn't fathom it at the time.
Yeah, and I remember we were talking off screen about I learned about this in grad school, and I learned that this was one of the biggest ships in the Great Lakes at the time. So to talk about that ship itself, it was one of the bigger ones in the Great Lakes, right?
Yeah. So when it was built in the 50s and launched, it was the biggest ship on the Great Lakes at that time. And I think that's why they designed it that way. It could just fit through the locks, the Sault Ste. Marie locks. It was that, they designed it to be as big as it could be so that it could carry as much ore on each individual trip that it made. And during that, because it was so big, because it had such a big engine and can travel 16 miles per hour, which again may not sound like a lot, but what a big ship carrying that much ore, that's really humming along. And as a result, it set a lot of shipping records during its history on the Great Lakes. And every time it broke a record, it was basically breaking its own. It still remains, it was the biggest ship to go down in the Great Lakes, and it still remains the biggest ship to have sunk on the Great Lakes.
Yeah, and just kind of take me back to the days leading up to when it eventually sank. Were there any talks of the ship maybe staying in port due to the weather? What was the weather like days before? And I remember you saying something about they took an alternate route based on the weather forecast, and it ended up being a wrong forecast, which, ended its demise. But, kind of just take me back to the days that led up to that sinking.
Yeah, so when they're loading up the ship, the way they load it up is with talconite pellets, which are like iron marbles. And they just pour them down chutes into the hull. And there are 21 different hatchways that they pour them into, and then they seal them all up. On that particular day, on November 9th, it was a beautiful day. And even the other ship that traveled with it eventually, the Anderson, which was another ore ship, that captain there, they survived the storm. That captain pointed out that it was one of the most beautiful days on the Lake Superior. Beautiful open skies, blue skies, and the lake was really, really calm. So they were ready. They've been in storms before. Later that afternoon, the National Weather Service, or NOAA, issued a storm warning for the lake. But again, those big ships have been on the lake in storms before. It's just got a lot worse than anyone had predicted at the time.
Yeah, you mentioned something about how it was that wind direction change that was the big difference, where I remember you saying they were expecting a northwest wind, so they took a different route, and then it ended up being the northeast wind, which out on Lake Superior, that easterly wind component is the reason why you can get some of those big swells, but that westerly wind component, not really. So that's what they were mentioning with that alternate route, was the wind direction change.
Yeah, exactly. So they were initially going to take the more southern route, which is shorter. But given the gale warnings that were being issued by the Weather Service and the directions at the time, they realized, well, if they took that route, then the way the storm was moving, they would be exposed to the strong sustained winds. And so by going further north, it would take longer, but then they would have some protection from the land as they were close to it. Plus the amount of open water, which we call the fetch, would have been less if they took that further route, given the forecast that was there. And the fetch and the sustained wind are two of the things that drive how big wind-driven waves are going to be. And so that was the reason for going that far. And the thing to remember, of course, is that this is 1975. And so weather forecasting, particularly the numerical prediction, is still relatively early. It's only about a decade old. And so, weather forecasters are using the observations that they're seeing, the weather maps that undergrads were hanging in the weather room, as well as the output from these numerical weather prediction models to do those forecasts.
Yeah, you bring up some pretty good points. NWP, fetch. I mean, everything that I learned in grad school just 3 years ago, that was kind of back then was a different topic that, was kind of a newer topic, especially with NWP. I remember, in grad school learning about the history of those numerical weather models. So, that's some kind of a question I'll ask down the line. But, just kind of take me back to that day, November 10th, 1975. What was that weather forecast like, or what was the weather that the Edmund Fitzgerald experienced that day? And, in your professional opinion, what caused it to break and eventually sink?
Yeah, so based on the weather forecast that they received, they ended up taking this northern route. When they got up there, as they're continually doing weather updates, the National Weather Service updated their forecast, still maintaining really strong winds, 39 to 55 miles per hour, sustained winds. But now the storm has developed and intensified more than expected, so that by the time they're up by the northern end of the Lake Superior, heading to Sault Ste. Marie, the wind is no longer coming out of the northeast, as predicted. It's coming out of the northwest. And so if you think of the Lake Superior, how that's orientated, that means it's coming down the full length. That sustained winds of 50 miles per hour are coming down the full length of Lake Superior, which means you have a really big fetch, you have sustained winds, you have deep waters, all of which are going to contribute to waves that are observed at as well as predicted later, as we figured out how to predict waves better, of 25 and in some cases 30-foot high waves that they were exposed to and coming right out the back of the ships.
Yeah, I mean, both of us come from the East Coast where we're used to the oceans, but never would I expect that you could generate 25 to 30-foot waves out there on Lake Michigan. I mean, or Lake Superior as well. I would never have thought you could generate that type of wave action on Lake Superior.
Yeah, as you were pointing out, we both grew up near the ocean and we would
Yep.
go body surfing. And with the shoreline and the winds, if you got a 10-foot wave, that was a pretty big wave. And so, yeah, that was another thing that was really hard for me to fathom as I looked into that back in my undergraduate days. So, a 25-foot wave on a lake. But that just shows you how deep. I mean, Lake Superior is the second biggest lake in the world. I mean, you can take all the other waters in all the other Great Lakes and dump them into Lake Superior and still not fill it up. So it's a huge. I don't want to say it's like a big bay in the ocean, if you will.
Yeah, and when we do our forecast for marine forecast during the summer, when people might be going out to the beach, it's always for us here in Lake Michigan, 1-footers. 1-footers. The only time that you get 2 to 3 footers, 3 to 5 footers is when you get a wind. Back where we're from, you have a hurricane turning through like just to the north of Bermuda or south of Bermuda, and you can get 3 to 4 footers as the bigger waves start to push towards the coast. But I just had to wrap my head around the fact that we can generate those type of waves just by the wind out on the lake. So that was different concept for me to learn when I moved here. Obviously, learning the weather patterns here, it's a lot different than mountain forecasting or marine forecasting that we've grown up to back out on the East Coast.
Yeah, and as amazing as it is, for the ship captains, the pilots, the people who have worked on the Great Lakes for many years as part of their career, they're used to those 20-foot waves, right? I mean, there were other ships out on the lake at the time, along with the Fitzgerald, that didn't sink, that survived those waves because of the experience of the pilots that were steering those ships, and the secureness of the ships as well. It's not to imply that McSorley, the captain of Fitzgerald, didn't know what he was doing. He was a very experienced pilot of the big ships.
Yeah, and kind of like a meteorology side of things. 'Cause obviously, we always think about pilot error or captain error in these scenarios, but the nature of the season is obviously a big reason why, unfortunately, the Fitzgerald sank. But we know it as meteorologists as to why fall can be the most dangerous type of year for marine conditions out on the lakes. But explain to the viewer at home why that fall season is the most treacherous for these ships that are going out on the lakes.
Yeah, so the fall season is when we're now getting into the wintertime, when we have this transition from the summertime convection to storms with cold fronts and warm fronts, what we call extratropical cyclones or mid-latitude cyclones. These are the systems that I'm sure you're all getting ready to be talking about as we enter approaching the wintertime. One of the things is that the other thing that supports it, when you look at these mid-latitude storms that affect the Great Lakes in November, they traditionally develop in Alberta, Canada, intensify, and then just clip by the northern Great Lakes area. The other area where they form in November is just east of the Rockies, down in the Oklahoma Panhandle. They begin to intensify there and then head right up towards the Great Lakes, intensifying when there's an upper level jet stream to allow that surface low to build, as we happened in this case. And then when it gets up to the lakes, because the lakes are at this time of the year so much warmer than the air above, that also then intensifies the weather system that get encountered in early November before the lakes start to really cool down. They're still warming up in comparison to what the air above is doing or the land around it. So those are the severe. Yeah, go ahead. Right.
No, I was just thinking of like this is the season where we think about water spouts as well, because you got that temperature difference just a few thousand feet above.
Yeah, and also I was just looking at the Great Lake temperatures currently, and they're really warm again, which then gets you thinking about, okay, snowfall. lake effect snowfall, if it stays really this warm, and if you love snow and you live along the shoreline, you may be seeing some extra snowfall this year,
Yeah,
which
I
excites some
love.
meteorologists, I know.
I'm one of those. I love the lake effect snow. I'm a diehard New England Patriots fan. But I love the Buffalo games where you have the lake effect snow. I'm going to miss it when they get that almost dome stadium that they're building. But I love how you get that lake effect snow event and it's just snowing on top of the game like crazy. You see those crazy snowfall rates. Jim Cantori doing live shots in Buffalo. I just fascinate over that stuff. And we did some lake effect snow studies in college, and man, it's so cool to see those snow totals ramp up to 50, 60, 70 inches of snow over 3 days. I mean,
Right,
lake
right.
effect snow is just some of the coolest things I know that I didn't know how to forecast.
Yeah, yeah. And again, we get surprised, you and I, about the size of a wave on a lake.
Yep.
I'm sure that people who don't live around the Great Lakes get surprised by how can you get that many feet of snowfall, right?
Mm-hmm.
And you got warm water, and that's just going to evaporate and feed the storm and generate snow.
Yeah. But you mentioned something about the NOAA forecast back in the 70s when this event happened. And, obviously mariners look at things like marine forecast, and the Weather Service issues those gale warnings, storm warnings, stuff like that. I think you kind of alluded to it, but those were around back then. And, how early in the stage of, those advisories, how early were they?
So so the weather forecasting was occurring. They were issuing warnings, and because of the severity of the storm, they kept updating those warnings. From gale winds, or from initially thinking it's coming out of the northeast, to realizing, oh no, the storm's intensifying more, so we're going to give another marine warning. With the winds coming out of the northwest, still at gale force, 50 miles per hour or so. So yeah, and I think as we look back, we were talking earlier about these November storms. There were three storms in my mind that were essentially the same, and one of those was the Edmund Fitzgerald. The other one that really affected this area was the Armistice Day storm of 1940. And that wrecked three ships on Lake Michigan, and killed almost 150 people. And a lot of those people were because they were duck hunters. And just like November 9th of 1975, on that particular day, it was beautiful. And so duck hunters went out in short sleeve shirts because they didn't have the forecasting and the communication to warn people of what was coming. And that led to a lot of tragedies in that Armistice Day storm. By 1975, we have, numerical weather prediction is on the order of 10 or 15 years old at most. It's getting better. It's getting improved. This is the beginning of the GOES era of satellites as well. This is the 50th anniversary of the GOES satellites that I'm sure you use all the time to monitor clouds and the weather. But again, not perfect. So the forecast was off. People were listening to that forecast, made adjustments to their path. In the end, that worked against what they did because of what actually occurred during the weather when the forecast was off. And then by 1998 is that third storm. Again, it almost has the exact same path as the 1940 storm and the 1975 storm. But in this case, we have a lot more sophistication. We have better technologies, better computers. And so the weather forecast for that storm was pretty spot on.
But yeah, so it's kind of going back to it. So do you know exactly when, gale warnings, storm warnings, those small craft advisories were, first issued? Because that's what I was kind of wondering is like, I know they issue those routinely out on the lakes, but I know you mentioned that for this event, they were being issued. So, was this a new type of warning or, advisory system that the Weather Service had around the time of the Edmund Fitzgerald? Or was this, way before that time?
No, it was way before that time. It's based on the Beaufort scale that I think came out of England. I'm not sure what decade that was in, but I think it was in the 1800s where they started looking at size of the waves and issuing warnings based on that. But I'm not sure. You probably can look it up and figure it out. But I'll look it up too when we're done.
That works for me because I'm always curious about it because everyone tells me about, these new snow squall warnings. I see these popping up once in a while. That's a very new warning. So I just thought maybe, this was something that was a newer type of warning system back in the day. So it's good that you clarified that it was well before that. But,
Yeah.
kind of a personal question for this one. But what fascinated you the most about the story of the Edmund Fitzgerald?
I think what fascinates me is the development of that storm and how you can use the history of that storm to look at how weather forecasting has improved since 1975 as well. And then the other thing that really fascinates me is that, with all the interest in this storm and the sinking of the Edmund Fitzgerald, we still do not know what made it go down. There's a lot of theories. We know water had to be getting into the boat because they reported a list, which means they're taking on water and they're tilted. So we know water is getting in there. But that boat, which is over 750 feet long, was gone in like 5 minutes. There it was, and then it was gone. And there's no eyewitness of how that went down. And to me, that's kind of the fascination part. The storm took down this big ship, took it down so quickly. We'll probably never know why it actually went down. And then, of course, Gordon Lightfoot comes out a year later with a really popular song that's easy to sing to.
Yeah, absolutely. I don't think I've actually listened to the song, so that might be on my gym playlist later this evening when I'm lifting weights, listening to that song. But you mentioned kind of something earlier about so it was on radar and then it just went off radar right quickly. That's kind of what was the lore about it. It was there and then it was just gone.
Yeah. So there was as it's taking on water, the Fitzgerald's getting lower and lower in the water, which is causing its problems. They have their own radars that they're looking for. Whitefish Bay was out of the site there was out. The lighthouse was there. It was out, so they couldn't send out a signal. So the Fitzgerald couldn't intercept that and find out where it was. And so the Fitzgerald was traveling with another ore ship, the Anderson. And as the Fitzgerald is having its troubles and it's lost its radar, we don't have GPS at the time, so it doesn't really know where it is because it's dark and there's a storm happening. So it asked the Anderson, the other ship, to guide it. So the Anderson's radar is fine. It can see the Fitzgerald on its radar. And so it's giving it directions of where it is or if there are other ships in the area and if they're going to miss those ships and making sure that they're traveling safely. And then all of a sudden, during the storm, there's a snow squall that goes through. Remember, this is 1975. Radars back then aren't what they are today. And so the radar that's on the Anderson, that snow squall obscures its ability to penetrate it and see the Fitzgerald. So it loses sight of the Fitzgerald. And then all of a sudden, like squalls we see in the upper Midwest here, it's gone. And it's beautiful outside or a clear sky, still very windy. And the Anderson's looking for the Fitzgerald on its radar, and it can't see it. It can see other ships, but it can't see the Fitzgerald. And so that, again, is part of that mystery of there it was, and now it's gone.
Yeah, it's certainly a little bit of a mystery there for sure. But we have about a little under 6 minutes left, and I have two questions that I really kind of a nerdy perspective for me since I'm a meteorologist and I love this kind of stuff. But, for the first one for me is I kind of alluded that I was going to ask you about this earlier, but how has better weather forecasting helped improve the quality of these marine forecasts to prevent another one of these scenarios?
I think there's a couple of things. One is observing technologies have gotten a lot better. As I was saying a little while ago when we were talking, this is the 50th anniversary of the GOES satellites. At that time, we could get, when they first launched that 50 years ago, we could get where the clouds were in those storms and track them that way. Now, some of that data from those satellites is actually feeding the numerical weather prediction models. And the numerical weather prediction models have found more and improved ways to take that data, whether it's from satellites, ground-based radiosondes, and incorporate it into the forecast so that the forecasts have become much better today than they have been. And then the other thing I would add is the communication systems, right? It's not just about forecasting good weather. There have to be professionals out there who are going to get that information out to the public and to industries as well about the threats that they may be encountering based on what the weather forecast model is.
Yeah, absolutely. Really good points there. And, kind of from a meteorologist perspective as well, from this event, what did we learn from this kind of from, weather perspective? Do we have to be better in certain areas of forecasting? Do we have to do better at communication? Because that's always, when you get these tragic events, we kind of have to learn like, okay, can we be better here? Can we be better there? So did this event kind of trigger that, or some other perspective that I didn't list down there?
I think this event, this tragedy, certainly triggered changes in shipping. But in terms of the weather, I think one of the things that it helped emphasize was, it's great and it's important to have these radiosonde observations so we can identify where the jet streams are. But all of a sudden, we're entering a new era with satellites. And so that not only can we see where the clouds are, we can see what the water vapor structure is in the upper atmosphere and therefore locate where the jet streams are and feed that information into the numerical weather prediction models, and then have the experts to look at that output, look at the observations, and then make a good forecast based on that.
Yeah, that's absolutely really good points there, that we have, as good as the models are, the professionals have gotten a lot better as well as forecasting these events to, prevent another Edmund Fitzgerald. But those are the questions that I wrote down. Is there anything that you wanted to mention before we wrap this up here?
The only thing I'll mention based on what you said about the professional is that, we can't forget the importance of the professional meteorologist. Sometimes it's a lot easier to, whip out your phone and look at what's the weather going to be. But, and that's okay. I'm not saying people shouldn't do that. But when storms are approaching, you really need to go to the professionals because the models aren't perfect yet. And so it's really good to have that local knowledge to really forecast what is going to happen.
Yeah, like we, in those events where it's happening live, it's happening in real time, as good as you can get that information from your phone, having someone, I feel right there communicating it to you, it's invaluable. It's still going to be here for a long time, no matter how things evolve. And you mentioned too, like the models, as great as they are, they can also not be the greatest. So, having someone to interpret and say, I don't really know if that's going to happen. You need to have that still.
Yeah, totally agree.
But I think we're getting pretty close on time. So I just want to say again, thank you for joining us this afternoon. I really appreciate it. And you had a lot of really cool things to say.
Thank you. I appreciate talking with you.
Yeah, absolutely. So once again, thank you for joining us on this special interview, I should say. And the actual show from Discover Wisconsin will air right here on WFRV on November 10th at 6:30 p.m. So once again, thank you for joining us, and we hope you have a great rest of your day.